Earlier this week, you learned about forces and how to draw a free body diagram that includes all of the forces acting on an object. Today we're going to combine that knowledge of forces with some of our knowledge of motion, of velocity and acceleration from before, to learn about Newton's laws. To understand Newton's laws, we need to understand how forces and the motion of an object are related. So we're going to look at a couple of different cases. The first one is if forces are balanced. If forces are balanced, that means that all the forces acting on an object would cancel each other out. For example, if you had a force to the right and a force to the left, if those forces are balanced, they would cancel out. This idea that all forces cancel each other out leads us to make a conclusion about the acceleration of the object. That conclusion is that acceleration equals 0 meters per second squared. If there's no net force, then there's no acceleration. Net force is just like net pay. It's what you take home after taxes. So net force is what you have after you add up or subtract all of the forces that act on that object. If all the forces cancel, your net force is 0. If your net force is 0, your acceleration is 0. Knowing that the net force is 0 and the acceleration is 0 leads us to conclude that the object must be doing one of two things. So what are those two possibilities for the motion of the object? One possibility for what the object can be doing is sitting still. The science term for that is at rest. When an object is at rest, its velocity is 0 meters per second. The other option for what that object could be doing when all forces are balanced is that it can be moving at constant velocity. That means it's in motion and its speed remains the same. So there's no acceleration and no net force. And these two options lead us to the first of Newton's laws. You've probably heard this saying before. An object at rest stays at rest. And an object in motion stays in motion. Next, we'll write those out in phrases, and we'll add a little bit more to that. So we'll have the full version of Newton's first law. Newton's first law is called the law of inertia, and it has 3 parts. Part 1. An object at rest will stay at rest. Part 2. An object in motion will stay in motion. Part 3. Unless acted on by an outside force. And this is the new part. An object at rest will stay at rest. An object in motion will stay in motion, unless they are acted on by an outside force. So why is this called the law of inertia? To understand that, we need to know what inertia is and is not. First of all, inertia is not a force. Instead, it is a mass's ability to resist a force. Here's an example. Driving down the highway, there's a small car next to a large semi. Which of them takes more force to stop? The semi, because it's more massive. That means it has more inertia. The semi is better able to resist the force of the brakes than the car, so it takes more force to make the semi stop. Here are a couple of examples of Newton's first law. A rolling basketball would continue to roll forever if an outside force did not act on it. The outside force that makes the basketball stop is the friction between the ball and the floor. Here's a second example. A rock will never move unless an outside force moves it. This would be an applied force, applied by you, applied by the wind, applied by water. I'm sure you could think of a few other things that could apply here. So Newton's first law comes from the two scenarios where forces are balanced. Newton's second law, then, comes from the scenario when forces are unbalanced. If forces are unbalanced, this means they do not cancel each other out. If forces are unbalanced, that means that the mass or the object accelerates in the direction of the larger force. And that leads us to the relationship between force and acceleration. And just like we've seen before, relationships can be written as equations. So here's our equation. The net force on an object is equal to the mass times the acceleration. We've already mentioned this once, but net is kind of like saying total. Look at all the forces you have, add or subtract if you need to, and F net is whatever you have left over. Forces are measured in a unit called newtons. The symbol for that is a capital N. Mass is measured in kilograms, and acceleration is measured in meters per second squared. And now that we know the relationship between force and acceleration, we're ready to write down Newton's second law, called the law of force. Newton's second law then says, if a larger force exists, then there must be an acceleration in the direction of that force. In case you would like to use the algebra triangle, you can take that equation, F equals ma, and put it in to make your math a little bit easier. Force goes in the top of the triangle, then mass, then acceleration. Remember that force is measured in newtons, acceleration is measured in meters per second squared, and mass is measured in kilograms. To use your triangle, cover the thing you're trying to find, and whatever is left tells you what to do. And we have one law left to talk about. Newton's third law is called the law of action and reaction. It says that for every action, there is an equal and opposite reaction. One example would be the space shuttle launch. There is a force of the fuel pushing down, so the rocket is pushed up into the atmosphere. The fuel pushing down is the action, the rocket being pushed up is the reaction. Another example could be a frog swimming through the water. The frog pushes the water behind him, and so he is propelled forward. For every action, there is an equal and opposite reaction.